I did a video a few weeks back of how to repair an LED backlight on a LED TV. Repairing the LED backlight, basically, in that video I covered replacing the LED lamp direct. So rather than doing this method which I show in this video, I literally desoldered the old failed LED lamp that I diagnosed and soldered a new one in the original position. However, a lot of people have been messaging me saying they don't have a hot air station to do such a repair, and they can't do the repair or find the strips or blah blah blah, but they have strips on hand. And I'm going to show you an easier method, and all you need for this is a soldering iron and some LED strips from a smash screen LED TV, and you can repair the backlight easy. I have a tech called a 32-inch here. It's the same panel as the one that I shown in the other video, but it's the same for all LED TVs. And I'm going to assume it's a LED backlight fault here. So the TV is actually on at the minute, and there you can see the outline of the no signal frame on the LCD screen. I hope I can see it a lot better in person, but the camera doesn't appear to pick it up very well. I'll just get my Vestel remote here. I'll tell you what might be easier to turn that on there. Might be able to see the screen a lot better. I can see it a lot better with that other light on. And if I just change the volume, you can see that a lot easier as well on the camera. Well, so I say. But basically what's happening here is the LCD screen is working but the backlight isn't, so of course without the backlight you won't get any image at all, because LCD TVs require the backlight to work before you get any light emission whatsoever from the screen, whereas something like a plasma, each pixel generates its own light, so it doesn't require a backlight to light the screen to create the colour. And I'm going to put my bets that this is a failed LED in this one, but I'll just go through the diagnosis steps that I take in this video again, and then we're going to do what's called the stacking method of repair on the backlight, which is where you stack a replacement strip over the failed LED and you wire it into the original strip circuit, and basically you just bridging over the LED essentially with a working one, but you're not replacing it directly like I shown in the other video. Some argue that it's more reliable to do the stacking method because you're not heating the LED, but I've had, out of all the LED TVs that I've replaced the LEDs direct, I've never had one come back yet, and some of them have been gone nearly a year and a half now. So it's pretty safe to say either method will work, but this video covers the easier method of the stacking repair. So I'm going to take the back of the TV off and get my multimeter, and I'm going to check the LED drive voltage first and make sure that that's present. And if that is all good, then we're going to tear apart the panel and start testing the LEDs in the screen. I've just gone into the menu of this and I've set the backlight to low. I can actually see on the LCD screen the menu. I can't on the camera, but I doubt the camera will be able to pick it up. I've just set the backlight brightness to low on here, so you can see how bright it gets with the whole screen disassembled on the lowest setting. Just so I can see, how hard they push the LEDs in this. So here's inside of this Vestel LED set. This one uses a absolute tank of a power supply, 17 IPS 11, which has the LED driver built onto it. This connector here goes straight to the LEDs, and the driver is built onto the power supply. These power supplies aren't that bad compared to like the 17 IPS 19s. They're a lot more common failure, like prone to failures with the diodes. I've never seen one of these fail and blow out the diodes, so I think it should be alright, but still it's a piece of shit power supply. And mainboard's a 17MB82-2. And the LCD panel is a VES315WNDS, which is actually a Samsung LSC 320 APO1 or APO3, or I think APO6 as well. They're the same screen, which has one massive tab-on driver to drive the whole display, which I'll talk about that in a minute. I've got the set in standby right now, and what we're going to do is test the LED drive voltage. On these Vestel ones, it starts off at 24 volts, and the power supply boosts or turns on the booster, and if the booster detects that the LEDs aren't drawing the current, it shuts down the driver and it goes back to 24 volts on the output. So I've got my meter set up. Put your black probe onto chassis ground, and then you're going to test the red pin on the connector here. You can do it on either end. But you want to test the red pin, and it should go to about, I think, 80 volts on this, 80 or 90 volts. And if the driver stays on and it's working, it stays at whatever voltage, but if it fails, it drops down back to 24 volts. And pretty much if it drops back down, you know you have a faulty LED. But if it acts weird, you need to check the return line voltage, which, if it stays at 24 volts on these, that also means you have a bad LED in the screen. So this is in standby right now. The 24 volts doesn't appear to shut down. It's a little high. So the booster starts up and slowly the voltage is going down. And that will go back down to 24 volts. So we're going to put the set back into standby. And now we're going to check the return line, which is the black wire on here. We should be seeing about 24 volts come back through on this. Yeah, but we see about half the voltage coming back through this, which isn't good. So that means that we have a faulty LED in the screen. As I suspected, of course. I've done so many of these LED TVs, in theory I don't even need to diagnose the power board, but it's just safer to, because if you don't want to tear the whole screen apart and find out it's a power board fault, you should always diagnose it first. But the power board / LED driver is working. So now we're going to have to take this panel apart now. I've already done this quite in depth in my other video, so I'm just literally going to take this apart and then get back to you. One of the reasons why these TVs fail so prematurely is because of how cheap they're designed. You see this here? This has an IC on it, a chip on film, and it's called a tab-on driver IC, which is responsible for addressing and deselecting every row on inside the LCD screen. Typical Vestel or Samsung, well, it is a Samsung LCD glass, however Vestel probably got them to custom build it and told them to only have one tab-on driver for the whole display, which, if you know anything about older TVs, at least a 32-inch from about 2008 or so would have at least 6 tab-on drivers to all take the load of driving the screen. This has one, so this one tab-on driver drives every single row on this panel, and it probably gets quite hot as well. I mean, the LCD screen, I'd say it uses quite a few watts, if you know what I mean. The LED backlights use about 32 watts or so from what I calculated, and that leaves 30 watts for the main board and for the LCD screen as well. So it must use a fair bit, and I mean, if they heat sunk that IC properly, you know, it might work a bit better, but when that fails, normally the whole screen won't work if that one tab 1 driver fails. And the only way they heatsink it is with this little pad there. And what I do is I add thermal paste to that pad and the IC so that it can actually transfer heat a lot better rather than just touching up against the thermal pad. So what I'm going to do is take this tab bond driver board out. It's held in with clips. Just use a pair of pliers and squeeze the clips together and undo the board. Then what I do is I add some blue tack on the end here, blue tack on the end there, and I just slowly push this board down, because using electric tape with, you know, a screen that only has one tab bond driver like this, you can damage it. I used electric tape in my other video, which on that screen it had 2 tab bond drivers, which, you know, meant that the load was even, but with this it's not. So you have to be pretty careful with this, and also the LCD glass is very fragile, so, and it doesn't take a lot to crack it, so just handle that really carefully. Then I'm going to take the frame and the diffusing layers off as well, then I'll get back to you. Okay, so I've torn apart the LCD panel here, and we're down to the LED strips. It's the same typical Vestel ones. These Rev 0 type with 11 LEDs per strip. And there's 2 strips, so there's 22 LEDs for this panel in total. Now I'm doing this a bit different today. And I did mention in my other video, you can test these LEDs with your multimeter. And I did sort of show it when I'd replaced the other one. And somebody wanted me to, you know, show them how to do this. It's easy to do. We're going to test this one, for example, now. See the positive input there? The positive goes before the start of each LED, so the positive on these strips is, you can sort of see the trace there, comes out of the back of one LED and then goes into the front of this one, and you put the negative probe there. Pretty easy to do. But before we do that, we're just going to test the connections between this branch off board here and the actual LED strips, just make sure that is okay before we even dare start testing the LEDs, because that's quite an involved process. So I'll just get my tripod set up here. Okay. So I've got it in diode mode here. When it's a short circuit it beeps, so with the positive input of the first string here, I think that connects over here. That's a beep, so that's good. And then the minus output goes into the positive of the second strip. That's good. And then the negative output of the second strip goes to the return. So that's also good. So these connections are indeed okay, but I'm still going to modify them afterwards anyway. So now we're going to test the LEDs, and it's easier to do it on the second strip because I haven't got enough room in this panel. So if we do this one, for example, here, I'm going to scrape off some of the you can do it over here actually, it might be a bit easier to do. Choose your spudger or something that has a pretty sharp edge to it, like a knife or a flathead screwdriver, and you just scrape away the solder mask on here. Then you do it on the negative output. You see the separate traces here, and the negative output is the centre one on these Vestel LED strips. So keep your meter in diode mode because it provides enough voltage to at least make this illuminate if the LED is good. I might have chosen the bad one here, but indeed, you see the LED illuminates. And that means this LED is good, basically. So, and you just basically do that for the entire strip. Now we've already scraped off the positive input for this LED here, and we're just going to scrape away the output of it. see if this one's good. Yep. And basically if the LED doesn't illuminate, so say you've got your probes connected and it's not outputting anything, basically means it's failed. We'll just do a couple here, just to get you the general idea. But it's the same process for every LED. So I'm going to go along both these strips, and when I find the failed LED, because it only takes one to fail, as I said in the other video, only one has to blow up and then the whole lot won't light. So I'm going to test all these and I'll get back to you in a second. So there's two LEDs in this TV that are bad. There's one here and one here, and I'm going to do the stacking repair as I said. And the stacking repair for this one is going to be a bit more difficult because there's a smaller area to work on. So I'm not going to film that one, but I'll show you the result after I've done it. But I'm going to film the stacking repair of this one here. So I'm just going to show you that these both test bad as well. See if my camera tripod actually does what it's supposed to. So I've got this in diode mode again. Getting about 1000 ohms across that. Or 1000 millivolt drop across it, sorry. Which means it's basically open circuit. I'm getting the same across this one, and you notice that they don't light up at all. So that's bad, and that's bad. All the other ones, they light up when I test them, so that's okay. So I'm going to get my soldering iron on and heated. Then we're going to get some of the LED strips, and I'm going to show you how to do the stacking repair. Here's everything you're going to need to do this method. I have a strip of LEDs taken out of a smash screen TV. These are just some Vestel ones, but it doesn't matter where you get them from, as long as they're a similar type of LED. Full array type ones. And yeah, these have a little white reflector on them, and the lens is a different orientation, but it, you know, the light output, you won't even be able to notice any difference. I have a little spudger here so I can peel off the lens of this one. So we're going to take the lens off and we're going to remove this bad LED under here and just take it off the strip there. Use some silicone thermal plaster so you can mount the LED we're stacking over that on there and let it dry. Of course you need some solder. Now these resistors, I'm not using them to drop any current or anything, but you see this little wire on the end? That's what we're going to use to connect the new strip to the old one here. So I'm going to get this out of the way and then I'm going to show you how to do this. Okay, so I'm going to show you how to do this method. So the first thing we're going to do is take off this old lens here. Just pry that off, you can chuck that away, you don't really need it for anything. And I can see that the LED is actually burnt up on the corner there. See there's a brown mark in the top left hand corner. So put that lens aside and take the side cutters here. Just going to snip away this little rubber that goes around the outside, because we're going to desolder this old one. That rubber tends to melt sometimes, but just get that out of the way. So now we take our soldering iron and solder. And we're going to get this old LED off the board. It's pretty easy to do. I'm just going to have to move this over a little. There we go. You just flow some solder on there. It'll go brown, but you're going to clean this off after with flux remover. You just literally wipe that old LED off there. Now if this does short out, you want to make sure you unbridge that. And to do that you just clean your tip of your soldering iron. Just swipe off any solder that can cause a short circuit, because you don't want to short out this old LED there. If you do, the TV's just not going to work. Well, it might work, but I doubt it, if you know what I mean. So, and this solder that I'm using at the minute has a ton of like nasty flux in it, so that's why it's gone like really brown. But there's our old LED off, burnt up one. Chuck that away as well. So now that looks pretty crap. Spray some flux cleaner on there. Just clean off that, just so it doesn't look as hideous, and it allows you to, you know, just make sure nothing's, you know, shorting out anywhere. There we go. So if you're like me and you just want to be doubly sure that you haven't shorted out the solder pads, it doesn't look visibly shorted out, just use your multimeter and just put it in diode mode, and that's not shorted out, so that's good. So I've realised something about this LED strip as well, but we should be able to isolate that pretty easily. On the back here it has some aluminium, and that could possibly short something out, but I'm going to be using a fair amount of silicone thermoplaster, and I'll put a blob over these terminals so it doesn't short out at all. So what we're going to do is snip an LED off of here with the side cutters. Now, make sure you know the polarity of the LEDs, so this side is the positive, this is the negative. And you just get the terminals there. Right there, this is the negative side of this one. And make sure to hold the strip, because if not it'll go launching off. You just leave a fair bit exposed there, because that can actually act as a heatsink for this little LED there. And then you cut a fair amount off the positive side. Make sure you leave enough just in case if you use this one. It's pretty difficult to do, especially with an aluminium base like these have. There we go. So there's our replacement LED, and what we're going to do is set that over the original failed one to do this repair. So before we do actually set this on, we're going to scrape away the copper traces, and we're going to find the polarity and just make doubly sure we've got it correct. So scrape away the trace on this one. Now this scrape can also be used, you can use it to solder this back into place as well. So again, your multimeter come into play, and you just find the polarity of this. So put on negative probe there. So the polarity is where my red probe at the minute is, that's the positive input, and where the black probe, that's the negative. So that's how we're going to solder this. Let's turn the meter off again. So we take some silicone thermoplaster, and we're going to put some directly over the contact of this original LED there, just so it doesn't risk shorting out. And some of the copper that we scraped away, we're just going to put some directly over that. So this is going to go about there. So now I'm going to put some on the bottom. Now this is used to also help as a heatsink, but it's also used to help isolate things as well. So that should be a fair amount. I go through quite a lot of this silicone stuff. Now you replace I'll place this directly over the original LED where it was positioned, because that's how they get the light output, or you keep the light output the same. And if you just push this down on top, you should see the silicon, spread out across this. Now this might have got a bit bent up when I was snipping it there, so I can find the side cutters. Might just want to bend that up a bit more. Just bend it back into position so it's straight, so one side isn't pushing up, meaning that it doesn't sit flush. That should be alright. So if I place that down on there, just give it a bit of, push. Might need a bit more plastic. Probably put a bit much on there, and I'm probably going to get somebody comment on that, but you know what, oh well. If it works, it works. This TV's a bit of a piece of shit. It's not going to last that long anyway. So as long as we've got enough on there to hold that down, we're now going to solder on the wires. So we've already got our copper traces exposed there, so just going to scrape some away on this strip. And we already have a bit exposed on the negative side here, but we're going to scrape a bit more so we can get some solder on there. That should be okay. So now we're going to take our resistor lead and I'm going to tin off the two copper areas that we've exposed. Just get a little bit of solder on there, that should be enough. Same for this. Now this solder is really bad for the flux for some reason. So if you just get that on there, and it is moving a bit, but it's not that bad. Just hold that in place. When it does set, it will be solid. And snip that off. And that's basically how you just solder those two contacts on. Ta-da. So that's the negative side done. Now I'm going to do the positive. So just add a bit of solder there. Oh, crikey. Snip that off. Then of course afterwards we're going to clean up the excess flux there because it looks horrible. There we go. And that's how you do the stacking repair. That simple. I'll get my trusty meter here. We're going to put our positive probe on the positive input. And as you see, this LED is now lighting up. So I'm going to clean that up with my flux cleaner, let that set for a little bit. I'm going to replace this one at the same time as well. I'm not going to film that because I've already just shown how to do it. And I'll show you that when I've cleaned the flux off and replace that one. Then we will power this TV on and see if the backlight now works. So I'm going to finish this up. Replaced both LEDs and cleaned up the flux, and both of them light up now. So that should be good, but I'm going to do a modification to this connector board here, which over time the connection between this green board and the LEDs can go intermittent, and I've seen it happen. And if it does, you get no backlights again. So it's best to just completely add a solid wire bridge from the terminals to this branch out board here. Just means that it's not going to break off over time, and that you're not going to have to take this back apart anytime soon. So you'll notice on here there's a tab here. You just want to make sure, put your meter in diode mode, that this tab isn't shorting out. There's one here and one on the opposite side, and if it is shorting out, you can't use solid wire like this. You have to use some insulated type. So you just want to make sure that they're not shorting out to anything, which they don't. It's the same on all of them, but it's always best to check. Now I've already actually done this mod in the other video, but I thought I'd just do it for the people who couldn't be bothered to go and check out the other video. You just scrape away some of the solder mask on the branch out board, just using my side cutters. Okay, so I'm going to use this solder again, just clean up my line there. My soldering sponge is about to collapse, which is why my iron isn't ending up very clean. You just add a bit of solder onto the terminals. Whoops. Like that. Then you tim out the copper traces that you exposed. And if I could separate these, that would be good. So tack one in there, fold that around. Just make sure that was a bit neater there. Fold it around, tack it onto there. Trying to work quick here because my camera's flashing at me, but that's all you have to do. So I'm going to do the same on the rest of these, and then we'll give this thing a try before we seal it up. Okay, so I've got the TV plugged in and in standby. I've completed the mods. There's a stack and repair. So we're going to see if this worked. So I'm going to turn it on with a little toggle button there. I think we're booting up. There we go. I don't know if that's on low, but that seems pretty bright. I think that might have gone up to maximum brightness somehow, so I don't want to run it for that long, but as you can see, backlight is now working. There's the one that we stack repaired. Doesn't look any different from the others. And it doesn't when you've got all the diffusers and the LCD on either. It looks factory. So I'm not going to run this for long because I don't want to burn out any of the other ones if that's on maximum brightness. Turn that off there. So the repair has worked. So now what I'm going to do is stick everything back down. Need to add some more new fresh double-sided tape to hold the reflector down. And get all the diffusers back on and the LCD back on. I'm not going to film that. Just make sure you don't get any dust trapped under the screen, because if you do it'll show up when you actually running the TV. And we're just gonna let this set for a while. I mean, it's pretty much set solid now, as you can see. That's not even moving. That one might be a little more loose, but the backlight is now repaired, and I want to check what brightness that was on as well, because that was pretty damn bright. It looks like those LEDs were being pushed pretty hard. If it's on maximum, yeah, you know, I can see why it'll be that bright, but on LG ones, I did a 50-inch Toshiba LED backlit one, and when I first turned it on, it starts at maximum brightness, then it goes to, it was on the auto range, and I was covering the IR sensor, and it went to minimal brightness, and it was, the LEDs almost looked like I was, you know, when I lit them up with my multimeter, they were that dim. And that was on the absolute minimal brightness. But I wonder what this was on. I can only find out when I seal it back up. So that's just how you do the stack and repair, so I'm going to do that now. So, just about to seal everything up. Got some fresh double-sided tape on here, which all I've got to do is peel off the film, and then can stick the reflector down. Got my initial on there, got those LEDs marked up, even though it's pretty obvious which ones were replaced, and we're going to seal this thing up. One thing I forgot to finally mention about doing the stacking repair, the only problem is if you don't get the LED that you've stacked in the repair perfectly, you know, aligned with the original, it might not fit in the diffuser properly. This one is just barely in there, and that one's perfect. And I mean, you know, if you don't, all you got to do is just literally snip around the area on the reflector sheet, sorry, I called it a diffuser, and just make sure that you know, the LED is popping through the little hole properly. So I'm going to finally seal this up. Just getting the LCD back in here, you want to make sure it's perfectly aligned and not stuck up on any of the corners. If it is, and you go to put the front frame back on, you'll just crack the screen. Here's something I do, I just add some thermal paste to the tap-on driver IC. You can actually see the chip on the actual film there, and I just add some thermal paste on there just to help it cool a bit better. It won't damage the IC or anything. Yeah, that's something I do, so I'm going to properly seal this up. Okay, so I've got everything partially reassembled. We're in standby now, so we're just going to turn the TV on. Just make sure the LCD screen is all good. Backlight is on. Got an image. Sweet. So now I'm just going to see what the backlight brightness is on. I'd say it's probably on max. No, that's on low. So yeah, those LEDs are being pushed quite a lot hard. What I could do is remove the current sensor resistors for the LED drive circuit, but you know, I've sold quite a few of these TVs and I've set the backlight brightness to low, and you know, they've been sold over a year now, and I mean, some of them only survive probably about a year and a half or so. But I'm going to seal this up the rest of the way, as I know it's working now, and then we'll test it. And I'm going to reflash the firmware. I'm not going to re-diode this power supply, although I have added some thermal plaster to them just to help them cool a bit better. And then this TV should be case closed. Okay, so I've got the firmware upgrade plugged in, so when I turn this on I'm going to hold OK, and this standby LED will flash really fast. Oh, didn't work that time. Turn that back off. When it eventually turns off. There we go. That's going to reload the firmware for this TV. Let's see the USB stick there reading. Hope you saw that. That's going to upload a fresh version of the firmware, which is a common fault on these. Firmware messes up. So that could take a few seconds to boot up. But the stack and repair is for people who basically, you know, aren't that good at soldering, and you just have a soldering iron and not like a hot air station. That's probably all I can say, but I hope this video helps somebody. Now I'm just going to show you the TV all working. I'm going to test it for a few hours, even though it's like 2 in the morning right now. But I can't sleep at the minute, so I'm booting up. And advise this when you, as I said in the other video, and probably most other videos that I've done, whenever you get a TV, just factory reset it and just first time install it. Actually, before we do that, I like to remove the USB just out the TV there, just so the Vestel doesn't fuck it up, because Vestel, so many glitches with them. So this is going to tune it in from fresh and set up everything. There we go. Yes, home mode. So I'm going to do all this, and whilst it's on like a full solid screen, just go over the screen and just make sure there's no like pieces of dirt trapped behind it. And as you see, we're replacing an LED about here. The screen looks absolutely fine, and the other one was about there. But I'll show you that afterwards. It all looks good at the minute. So TV is all fixed. That glitching across the screen is just the signal. I've gone into the picture. Oops. And I've set it to dynamic on the Vestel ones, and then that allows you to set the backlight to low. That's on high. That's on low. In my opinion, the image quality actually looks better with the backlight on low. The contrast seems slightly better, and I also set the dynamic contrast to high. If not, the display just looks like just crap basically. So another thing I do then is I change the source over to just HDMI. So then what I do is I go settings, other settings, blue background on. That's a full solid image on there. You just go over the screen and just make sure that there's nothing trapped behind there again. If so, just take it apart and just clean out it. But I've done it all properly, so awesome. Another LED TV repaired. I've actually got a 40-inch Toshiba set coming in on Monday, I think. Oh, that's weird. SCART is apparently the Freeview on this. Oh, why have we not got Freeview? Oh no, sorry about that. I thought the firmware had messed up somewhere, but yeah, I've got a 40-inch Toshiba LED TV, same fault. And it's not just the Vestel ones. I mean, the Vestel ones do tend to fail, you know, quite a lot more, because they put less LEDs in the screen and then drive the existing ones a lot harder. So you maintain the same brightness whilst, you know, having less LEDs in the screen, which means that they save money basically. Yeah, I've got a 40-inch Toshiba coming in. I did a 50-inch Toshiba with an LG panel the other day, and that wasn't a Vestel set either. They're dropping like flies. But if you know what you're doing and you follow this video, it's cheap money for you. And, you know, just don't crack the panel basically. I mean, you know, I work from home and my room's pretty messy at the minute. I haven't cleaned it today. And I've got quite a few TVs that I've got to go up to the house where I store them. And I've never cracked a screen accidentally. I mean, I've cracked them on purpose, like smashing them up. But never accidentally have I cracked a screen. But as long as you're careful, you know, you should be onto a winner. And then after you've repaired it, also always set the backlight to as low as you can put it basically. So thanks for watching. Almost forgot to do the hour count on this. So you press menu, then 4725 on these Vestel sets. And this one has 278,188 minutes. So you do that on the calculator here, so 278 188 divided by 60 minutes in an hour. It's 4,636 hours, sorry. It's not that bad for a Vestel, I suppose, but still pretty shit. So that wraps us up finally. Thanks for watching.